Welcome to qnawire.
Hi, so over here what we are going to have is propanoic acid that has a concentration of 0.002 molar that I'm going to write down as 2 times 10 to the minus 3 molar in scientific notation. And we know that the pKa for this propanoic acid it is going to be equal to 4.87. And we want to know the percentage of ionization, alpha, at a pH equal to 6.3. So, first of all, the reaction that we are going to be treating, I'm going to abbreviate propanoic acid. Instead of writing the whole formula, I'm going to write it down as HProp, just to make it more simple for us. And we know that when it comes into contact with water, it is in equilibrium, and it is going to generate the propanoate ion. I'm going to abbreviate that as prop minus plus H2O plus. Okay. So now, first piece of information. We know the pH. So the pH is related to the concentration of H2O plus as 10 to the minus pH. So this concentration is equal to 10 to the minus 6.3. Okay. So with this, we can start our ice table that is going to be in mole per liter because we are given already the concentrations, and we're going to replace the values over here. So, of propanoic acid, we are beginning with 2 times 10 to the minus 3. Water, it doesn't matter, it doesn't enter into any equilibrium, so we can disregard it. Of propanoate, let's assume that we have 0, that is the ionized version of my propanoic acid. And of H2O plus, I'm going to have 10 to the minus 6.3. Okay. Now, the amount of change, let's call it alpha, just to have it directly related to the percentage of ionization. So here we're going to have plus alpha and plus alpha. And at equilibrium, we're going to have 2 times 10 to the minus 3 minus alpha. Here we're going to have alpha. And here we're going to have 10 to the minus 6.3 plus alpha. Now, we know because of the pKa that the Ka for this reaction is equal to 10 to the minus 4.87. So we can write down our equation for Ka that is going to be equal to the concentration of propanoate times concentration of H2O plus divided by concentration of propanoic acid. Replacing the values that we found at equilibrium, this is alpha, 10 to the minus 6.3 plus alpha, divided by 2 times 10 to the minus 3 minus alpha. So, right now what we need to do is solve for the value for alpha, and with that we can calculate the percent of ionization that we're going to get. So, the way to do this is, first of all, in this case, we cannot make a lot of approximations because we know that the K is 10 to the minus 4.87. But this value over here of 2 times 10 to the minus 3, my initial concentration, it is still kind of close enough to that value. Also, we have a very small value for the concentration of H2O plus. So we need to consider all of them in order to get our result. For sake of simplicity, I'm going to replace 2 times 10 to the minus 3 with C0, just to do the algebra. And this equation can be rearranged by passing the denominator to the side over here. This becomes C0Ka minus alpha Ka is equal to 10 to the minus 6.3 alpha plus alpha squared. We can put all of the factors together that have alpha and alpha squared, and we're going to get alpha squared plus alpha times factorizing over here. Here we're going to get Ka plus 10 to the minus 6.3 minus Ka times C0 needs to be equal to 0. Here we can replace the values. Remember that K was 10 to the minus 4.87. So this becomes alpha squared plus alpha times 10 to the minus 4.87 plus 10 to the minus 6.3 minus Ka times C0. C0 was 2 times 10 to the minus 3. So Ka is 10 to the minus 4.87 times 2 times 10 to the minus 3 is equal to 0. And we can solve this quadratic expression. This is a quadratic in alpha with coefficients 1, coefficient 10 to the minus 4.87 plus 10 to the minus 6.3, and the constant term with a negative sign. So the two results that we get for alpha, alpha 1 and alpha 2, are a negative 1, that is minus 1.7 times 10 to the minus 4, minus 4, and a positive 1 that is going to be 1.57, actually 1.574 times 10 to the minus 4. Which one is the only possible? Well, the positive value, so this is going to be our value for alpha. So now in order to calculate the dissociated version, the one that is ionized, so percent ionized, this is going to be equal to alpha divided by my initial concentration times 100, because this alpha that I calculated over here is equal to the ionized portion that I'm going to have in my molecule. So the result is a 7.87% is ionized. And the percent that is not going to be ionized is going to be, you can simply calculate it as this value minus 100, but if we look over here, this is going to be C0 minus alpha divided by C0, and all of this multiplied by 100, and the result is simply 92.13. And that would be all. Thank you very much.